Oh, hey, I didn't see you there. Well, now that I got your attention, let's get started. My name is Ryan, and today I'm going to show you an easily replicable experiment that you can perform in order to demonstrate some basic engineering concepts.
Materials required for this experiment include water and oil, along with food coloring to distinguish the two, honey, a glass, a ping pong ball, a bottle cap, a piece of sponge, a nail, and a grape.
The first engineering concept we'll be discussing is the separation of liquids by density. Although the idea is fairly simple, we'll check our theory with an example for good measure. Honey, the alleged most dense of our three liquids, will go first. Water will go next. And finally, oil.
We can now use these different density liquid layers to demonstrate the concept of buoyancy force. First, we will drop a nail into the liquid column and see that it sinks to the very bottom. Next, we will drop a grape and see that it stabilizes in the middle or water layer. Finally, the bottle cap, sponge, and ping pong ball will be dropped. As we can see, these last three objects are the least dense of the bunch and kept afloat at the surface of the column. Now that we've got an idea for how things work physically and conceptually, let's take a look at the mathematics behind buoyant forces and how they're largely affected by liquid density. Here we have our simulated tank of water in which we will demonstrate the buoyancy forces within a uniform liquid. For the sake of this example, the green circle will be used to demonstrate how the forces act on an object in water. The weight of the object is equal to the mass of the object multiplied by the gravitational acceleration of 9.81 meters per second squared. When in a liquid, weight and buoyant forces act on the object in opposite directions, constantly finding themselves in a battle of push and pull. The buoyancy force, F sub b, is equal to the density of the liquid, ρ, times the gravitational acceleration, g, times the volume of liquid displaced, capital V. Should an object be fully submerged in the liquid, capital V will just be equal to the volume of the object. If both the weight and buoyancy forces are equal, the object will not move up or down and stay at the settled depth within the liquid. If the weight of the object is less than the buoyancy force, the object will float at the surface. This can be seen in the real world as a boat or buoy. The buoyancy force is higher, and because of this, the object will float. For our experiment, the density of the liquid is crucial because it affects how an object will float in different liquids. Something might float in cooking oil, but it might not float in water. Even though the volume dispersed and the gravitational force is the same, the density of the liquid can change whether it floats in the liquid or not. However, if the weight of the object is greater than the buoyant force, the object will sink to the bottom of the liquid in which it sits. This is shown above and in the video example where the object might sink through one liquid but floats in another liquid due to its density. So now that we have a better understanding of the fundamentals, let's look at some applications of these engineering concepts. Here we have a general view of how submarines float and sink. They essentially change their weight in a liquid by adding water to the ballast tanks in order to increase mass and overcome the natural density of seawater. When they are ready to resurface, compressed air displaces the water in the ballast tanks and the submarine will rise to the surface. This is where the buoyancy forces overcome the weight of the object. And if you thought that was cool, here we have an apparatus in Brazil that generates power by harnessing energy from the up and down movement of waves. The yellow discs float on the surface of the water, and the waves move the discs up and down, which creates power. The weight of the discs and control arm need to be less than the buoyant force of the water in order for them to float.
Well, there you have it. Thanks for taking the time to learn with us today, and no matter what happens, always remember, science rules.